Okay, in this short video, we're going to talk about doing this task sheet 1E003, which is inspect and reinstall, replace pulleys, tensioners, drive belts, adjust belts, and check alignment. Okay, so we're going to do this two different ways. The modern engines all pretty much run what's called the serpentine belt, so it is a flat belt, not a V belt, and it runs around every basic component and has a spring tensioner that retains the proper amount of spring tension on the belt. We're pretty much making them now where the belt and the tensioner last the same basically, so if you put a new belt on, most manufacturers are recommending a new tensioner. This bolts to the engine. It has a drive here that you can pull the spring tension off to replace the belt or install it. It has a pulley here that runs with the belt. So what can go wrong with these is it has a bearing inside here that can go bad and get some play in it and start making noise. Most all the trucking industry has a steel pulley on it here. Automotive has some plastic ones that can wear out, but pretty much in the truck world we use the steel one. But what mainly happens on these is as this wears out, this pulley starts not being in alignment and starts moving because it gets wore out inside here where the spring mechanism is, and it starts making the belt track off to one side, and you'll start noticing like the edges of the belt having some wear pattern on them, and the outside ridge like worn away, some little strings hanging off of it. And if you look at it, you'll see that instead of this being perfectly lined up, the tensioner is out and it pulls the belt out and tries to make it run not true in the grooves on the pulleys of the other components. So that's pretty much what happens with these. Just remember that they're spring loaded, so they keep the right amount of tension on the belt. We really don't have to check the tension. The tensioner does all that for us, so we just have to check out the tensioner and make sure that it's still in good working shape. So part of this is for the old school stuff, like the white Freightliner here, which is what I want you to do the task sheet on. So on a visual inspection, we can see that it has the old V-type belts on it, not the serpentine flat belt. And it's a little hard to see in this video, but the edge of this belt, you see how it's frayed and there's pieces hanging off of it on its outside edge. If we get back even and look, you can see the tilt of the AC compressor. It's got the belts pushed farther out than normal. It's really hard to tell if I get the camera just right, but the fan clutch is in perfect alignment with this alternator. But up at the top, which is actually the tensioning part, the AC compressor is out farther, so it makes these belts run at an angle, and that's what's chewing up the belts and getting them frayed on the outside. So like I said, it doesn't do true justice on this video, but that compressor is about a ½ inch out from where it's supposed to be, so it's putting a real bind on those belts with the angle that it runs at, and those are matched belts, so both those belts are exactly the same length, but with it being angled out like that, the inside belt is carrying more of the load than the outside because the AC compressor is tilted down. So this belt has more tension on it than this one, so that's problematic. And that's all alignment stuff with the belt itself, or that brackets the AC compressor. So remember, safety wise, if you're going to be checking these brackets, make sure all the bolts and stuff are tight, because a lot of times that's what causes that. Make sure that the key's removed from the ignition and it's locked out, tagged out, or that you at least have the key in your pocket so that you can't have your fingers in the belt and somebody start the truck. That'd be problematic for your fingers. So that's the safety side of this. As far as belt tension, the task sheet is going to ask you to list what the proper tension for the belt is. So on these old V belts that don't have an automatic tensioner on it, you would have this belt tension gauge here. If you look at this closely, that's kind of upside down. Let me roll it over here, but this is hard to do by yourself, but we have Newton meters and pounds. This tells you that it's too high, so that's too much tension. A new belt is in this green area. So a new belt tension is from 110 to 130 pounds of tension. This black area here is either too loose for a new belt or too tight for a used belt. These are obviously used belts, so our specification is 70 to 90 pounds. And it says used belt there to tell us, so as long as our pointer is in this area, then we're going to be good on our tension. These old ones, if you didn't get them the right tension, because you do a manual adjustment on that, then you would have like alternator bearings or AC pulley bearings or something like that fail because they had too much tension, or the belt would slip because it's not tight enough. So the reason you have a different spec for a new belt is a new belt is going to stretch once it's installed and tensioned up. So it goes on a little tighter so that as it runs for the first hour or so and stretches out, it winds up down here in this normal range. So you put a new belt on tighter because it is going to stretch. As far as this tension gauge, right here on the handle, there's an indicator here. This indicator is going to line up with that scale when it's installed on the belt. It has a calibrated spring inside. It has a hand plunger here. So a little bit hard to do by yourself, or one-handed, I mean, but when you push this out, this part comes out further. So you're catching the belt between here and here. This is grabbing the back side, and the tighter that belt is, the less it can deflect it, so it determines where that this scale winds up on our pointer. So that's how it checks the tension. So I can't really plug this on there and video at the same time, but when I checked it, the belt tension on the outside was about right there. So I don't know if you can see on the scale, that's about 65 pounds. So that is too light because it's obviously not to 70, in that 70 to 90 range. Now, part of that is that alignment problem. If I could get it on this inside belt, it may be the right tension, but the outside belt, since the pulley is angled down, that's why they're reading two different tensions there. Eventually, this tool is going to be less and less used because everything's going to a serpentine type belt and not the V belt. This won't really work on the serpentine belt, but our automatic tensioner tensions the belt for us, so we really don't have to check it to make sure we got it adjusted properly because it's automatic tensioner.